We're going to start our journey solving system of equations by looking at how to do that by graphing. And you will determine whether a system of linear equations is consistent, independent, consistent, independent, or inconsistent. How can a system of equations be used to predict sales? Since 1999, the growth of in-source sales for custom creations by Kathy can be modeled by y equals 4.2x plus 29. The growth of her online sales can be modeled by y equals 7.5x plus 9.3. In these equations, x represents the number of years since 1999 and y represents the amount of sales in thousands of dollars. The equations y equals 4.2x plus 29 and y equals 7.5x plus 9.3 are called a system of equations. And they have solved it graphically for us because that's where the two lines cross. The ordered pair 654 is true for both equations. A system of equations is two or more equations with the same variables. To solve a system of equations, find the ordered pair that satisfies all of the equations. One way to do this is to graph the equations on the same coordinate plane. The point of intersection represents the solution. Solve the system of equations by graphing. So first I'd like to solve both equations for y. So x, I'm going to add 2y to both sides. So x equals 2y in that first equation and divide by 2. So I have y equals 1/2 x, and you could put plus 0 if you want to. The second equation, all we need to do is subtract x from both sides, and we have y equals 6 minus x, or we're used to seeing it y equals negative x plus 6. Those are both nice because now they're in slope-intercept form. So the first equation had a y-intercept of 0, and the slope was 1/2, so it's going up 1 over 2, up 1 over 2. The second equation had a y-intercept of 6, and it's going down 1 over 1. And the two lines cross at the ordered pair 4, 2. It's always a good idea to check, so I'm going to take the ordered pair 4, 2 and substitute back in. I guess I didn't need the parenthesis. 4 replaces x, and 2 replaces the y, and 4 minus 2 times 2 is 0, so that one worked. In the second equation, 4 plus 2, is 6. It is good. When checking a graph to find a solution, always check the ordered pair in both of the original equations because it could be true for one and not both, and that would not be good. I have not circled my answer anywhere. On the graph it's 4, 2, but we'd probably want to write it on our notebook paper as well. So the answer to the whole shebang was the ordered pair 4, 2. A service club is selling copies of their holiday cookbook to raise funds for a project. The printer setup charges $200, and each cookbook costs $2 to print. The cookbooks will sell for $6 each. How many cookbooks must the members sell before they make a profit? If we let x equal the number of cookbooks and y equal the number of dollars, the cost of the cookbooks is the cost per book plus the setup charge. So the first equation is y equals 2x plus 200. And the second equation, y, is also money, income from the books, is the price per book times the number of books, so y equals 6x. Now conveniently, both of these equations were already in slope-intercept form, so to graph my first equation I start at 200 and I'm going up 2 over 1, and they let their scale go by 25s in one direction, 50s in the other. So I'm going up 100 over 50. To get a point, and then the second equation is y equals 6x. So I have a point at 0, 0. I know I'm going to go up 6 over 1. So a convenient point to get, well, if we did 50, 50 times 6 is 300. So we've got 2 points. We can draw our line. Now to check, we're going to take the first equation. I'm going to see if it works. 300, does it equal 2 times 50 plus 200? Sure enough, 100 plus 200 is 300. And in the second equation, does 300 equal 6 times x there is 50. Sure enough, it does. So I know that the ordered pair 50, 300 is my solution. So the question asks, how many cookbooks must the member sell? They sell 50 cookbooks. That's really our final answer. Graphs of linear equations may be intersecting lines, parallel lines, or two equations that are different versions for the same line. A system of equations is consistent if it has at least one solution, and inconsistent if it has no solutions. A consistent system is independent if it has exactly one solution, or dependent if it has an infinite number of solutions. So we have two choices for consistent. This is what we've seen so far, consistent and independent. Intersecting lines, one happy solution. We could have consistent and dependent, same line, infinite million solutions. Or if the lines are parallel, they will never cross, so it is inconsistent and there is no solution. Graph the system of equations and describe it as consistent, independent, consistent, dependent, or inconsistent. This looks like a nice system to practice our x and y intercepts. If I put 0 in for x, I'm going to get -5 for y. And if I put 0 in for y, I'm going to get 5 for x. For the other equation, if I put 0 in for x, I'm going to get -2 for y. And if I put 0 in for y, I get -4 for x. So I've got two nice sets of ordered pairs. I can plot the points, draw the lines. Okay, so here's my first equation. It's got 0, -5, and 5, 0. Straight edge, draw the line. And for my second equation, I can get there's 0, -2. I have to use a little bit of imagination to see -4, 0. Their graph wasn't quite big enough for my purposes. But straight edge, draw the line, and we find that the two lines cross at 2, -3. Okay, this question wasn't asking for where their intersection is. It's just asking us to graph it. We did. And describe the system. So they cross at one point. The system is consistent and independent. If you're very intuitive, you know where we're going with the next two examples. I'm guessing this one will not be consistent and independent because the last one was. It's probably either going to be consistent and dependent or inconsistent, odds are. Okay, this is not a convenient one to do the x and y intercepts. I'm going to solve both equations for y. So we have 9x minus 6y equals -6. Subtract 9x from both sides of the equation. So we have -6y equals, I'm going to put it in the form we're used to seeing it in, -9x minus 6. Divide both sides by -6. And y equals negative divided by negative is a positive, so it's going to be 3/2 x. Negative divided by negative is a positive, 6 divided by 6 is 1. We're moving pretty quickly on solving those for y, but in the book they just go switch-o, change-o, y equals. So at least I'm giving you some here. I'm going to subtract 6x from both sides again. So -4y equals -6x minus 4, and divide by -4. So y equals negative by negative is a positive. 6/4 reduces to 3/2 x plus 1. Well, golly gee, the equations are exactly the same, so I know what my answer is going to be, but I still need to graph it. So we have a y-intercept at 1, and our y equals mx plus b. And our slope is 3/2, so our line is going up 3, over 2, up 3, over 2. And we've got some nice points. Straight edge, draw the line. And of course, because it's the same line, these graphs would be categorized as consistent and dependent. Okay, you know where we're going with this next one now. Well, once again, we're going to solve each equation for y. The first one, I'm just going to add 6y to both sides. That's kind of handy. So 15x equals 6y, divide by 6. And y equals, common factor is 3, so that would be 5 halves x. Second equation, we're going to subtract 5x from both sides. So I've got negative 2y equals, I'm going to go negative 5x plus 10, so it's in our order that we're used to seeing. Divide both sides by negative 2, and y equals negative divided by negative is a positive, and positive divided by negative is negative, and we can graph. So for the first equation, we had a y-intercept at 0, and we're going up 5 over 2 to get to our next point. The second line had a y-intercept of, nice, negative 5, which you can't see on the graph. And from there, we're going up 5 over 2. That's where we should be. Up 5 over 2. Lovely. Okay, the two lines have the same slope. Same slope means they are parallel. So we graphed it, and then they want us to classify it. So these two are just inconsistent. We will never get an answer that is true for both equations. So notice from equations that the lines have the same slopes, but they have different y-intercepts. The solution of a system of equations can be found by graphing the two lines and determining the point where they intersect.